Let's do a quick walkthrough of this problem, which says a 20-gram metal is heated to 47 degrees Celsius and placed in a foam cup calorimeter containing 40.0 milliliters of water at 17 degrees Celsius. The water reaches a temperature of 20 degrees Celsius. How many joules of heat energy were released by the metal to the water? And calculate the specific heat of the metal. So first of all, to think about what is going on in this problem, say we have a piece of metal. I'm a really bad artist, but this is our metal. Just label it as M. And we're heating it up, so we're adding energy to it until it reaches 47 degrees Celsius. Then we take this piece of metal and we put it into a foam cup calorimeter. So a foam cup calorimeter just means like a cup that is styrofoam, so it's insulated from the environment, and it has 40 milliliters of water in it. So I'll label this as W for water. So we put this mass of metal that's warmer than the water into the water, and that raises the temperature of the water. So we're assuming, because of the foam cup calorimeter, we're assuming that no energy from the metal goes to the surroundings, but that all of the energy that has the metal at 47 degrees C is being transferred into the water. So we can calculate the joules of heat energy by using the formula Q is equal to mc delta T. And since we only know the mass of the metal, but we don't know the specific heat of the metal, we can't use the metal information to help us to find the joules of energy. So let's use the water. So what this is the energy of the water is equal to the mass of the water times the specific, whoops, that should be a W, mass of the water times the specific heat capacity of water times the change in temperature of water. So we know that the mass of the water, because it is 40 milliliters, we know that water is 1 gram per milliliter. So because it's 40 milliliters, it's also 40 grams. So we can plug in 40 grams for the mass of water. And the specific heat capacity of water, I looked that up, and it is 4.184. And that's a unit of joules per gram degrees Celsius. I should probably keep my gram here for now. Also, the change in temperature of the water, change in temperature is the final temperature minus the initial temperature. So the final temperature is 20 degrees C minus the initial temperature, which is 17 degrees. So now we can just multiply all this out. If we do 40 times 4.184, and then 20 minus 17 is 3, is 164.36. So we get 164.36 joules, because the grams canceled, the degrees Celsius canceled with the unit of degrees Celsius from the temperature, and this would be the heat energy released by the metal to the water. We have 3 sig figs in this problem so far, so let's round that to 3 sig figs of 164 joules. So that's the answer to the first question. The second question says to calculate the specific heat of the metal. So let's write a new equation based on the metal. So we know that the Q of the metal is equal to the mass of the metal times the specific heat capacity of the metal times the change in temperature of the metal. And since we calculated the amount of energy that went into the water, we're assuming that all of that energy came from the metal. So we know that this 164 is the energy of the metal, although since it's being released from the metal, we would call that a negative 164, because energy that's released is negative and absorbed is positive. From here we can plug in the mass of the metal, which is 20 grams. We're looking for the specific heat capacity, so let's leave that as the C. And the change in temperature, we know that the final temperature is going to be the equilibrium temperature with the water. So if the water reaches a final temperature of 20 degrees C, that means that the final temperature of the metal is also 20 degrees C. So we can plug in 20 for our final temperature. Our initial temperature was the 47 degrees, and we can solve this for C. So if we divide both sides by 20, (164) divided by 20 is 8.2, so this would be negative 8.2 is equal to 20 minus 47 is negative 27. That would be negative 27C. So divide both sides by negative 27. So 8.2 divided by 27 is 0.3037. So our C, our specific heat capacity of our metal, is 0.3037, and rounding that to 3 sig figs is 0.304. That would be our specific heat capacity of our metal. So I hope this question was helpful for you. If it was, feel free to subscribe to my channel so you're notified whenever I make a new video. Also, leave a comment if you have a question that you'd like to see a similar video like this for. Thanks for watching.